So in the last video we have discussed regarding the theorems, Gauss divergence theorem, then Stokes theorem, and finally Green's theorem. So with that understanding, here we are going to start with some of the questions. So the first question here I have picked up this question. You need to find the value of this line integral. What is the value of this line integral where this C is the closed curve of the region bounded by these two curves, y is equals to x and y is equals to x square. Okay, so first of all you need to draw the diagram with the given information. So first of all you try to draw the diagram whatever information you have. So y is equals to x, you know this is nothing but this straight line. Okay, so this is y is equals to x straight line, and you know y is equals to x square, it is going to be something like this fellow. All right, so this is y is equals to x square. Okay, and immediately you can find out this point, this intersecting point. Simply try to solve this one and this one, and you will find x square is equals to x. So you have this one which will give you x equals to 0 and x equals to 1. So this point will give you x equals to 0 and y equals to 0, and this point will give you x equals to 1 and y equals to 1. So this is 1 point and this is 0 point. Okay, and you have this C is the closed curve bounded by this region. So if you consider this direction of anti-clockwise direction basically, so you have this closed curve as your C. All right, so we are all set to use Green's theorem because you have this C and this bounded region, it is also in your hand. So this is nothing but your R. Just recall the formula of Green's theorem. Now all you need to do is that you have this function m and this function as your n. They are smooth function inside and on this closed region. Okay, so no issue with that. So if you try to use Green's theorem, then what you have, look at this, over this R you have del n del x minus del m del y and dx dy. Okay, so what is going to be your del n del x? It is nothing but your 2x minus del m del y. It will be del m del y. So it will be your x minus, I think it is your 2y, and it is your dx dy over this curve R. All right, okay, so now try to find out the value of this fellow. So here it will be over this curve dx dy. So you need to find this double integral. So look at x minus 2y, here you have dx. So if you simply consider this vertical strip here, you simply consider this vertical strip, so in that vertical strip here you will have y varying from y is equals to x square to y is equals to x. So here y is equals to x square to y is equals to x, and here you are getting that x varies from 0 to 1. So if you simply change the order, okay, order of integration, so in that case you will have dy dx. All right, so here you will find that you are getting this value. Just try to calculate it. You will get x, think y minus y square, use the limit and do the rest of the parts. Okay, Fine. So here do the remaining parts. That I think you are going to get 0 to 1 x square minus x to the power x square minus, I think it is x cube plus, I think, x to the power 4 dx. Just verify it. And 0 to 1 x to the power 4 minus x cube, all about your calculation, nothing else. So here you will get, I think, 1 by 5 minus 1 by 3, 1 by 4. So minus 1 by 20 is going to be your answer. You should be very much accurate with your calculation. Okay, yes, the answer of this fellow, it is going to be minus 1 by 20 is going to be your answer. Okay, because it is a NAT type problem, all the hard works you need to do very much carefully, and special effort should be done on the calculation. Okay, fine. So this is your first question, and I hope you got the idea that how to proceed with such problems. Okay, so now we are going to start with our next question, and if you have any question or query related to all these things, you can easily go to the comment section and drop your comment. So now we are going to start with our next problem. So the next question, it is question number 2. So the last question, it was related with Green's theorem, and therefore I will move on to some other. Say this question here we are considering, say double integral you need to find over this s f dot ds. You just try to find the value of this fellow where this f is a vector which is nothing but 4xzi vector minus y square j vector plus yzk vector. Okay, and s is the surface, and s is the surface bounded by the cube x is equals to 0, x equals to 1, y equals to 0, y equals to 1, z equals to 0, and z is equals to 1. Okay, so basically you need to find this fellow. Okay, so this immediately you can have a flavor that this is nothing but relationship with surface integral to volume integral. So that means divergence theorem you need to use. All right. Okay, just recall what is your divergence theorem. This fellow will be equal with this fellow, divergence of f vector dv. All right. Okay, but before going on to this this calculation, you need to decide what is the bounded region. So x equals to 0, x equals to y 1, y equals to 0, y equals to 1, z equals to 0, z equals to 1. X equals, say this is your x-axis, this is your y-axis, and say this is your z-axis. So x equals to 0 this point, x equals to 1, say this point. Okay, y equals to 0 this fellow, y equals to 1 this one, equals to 0, z equals to 1. So ultimately you will have something like that, something like this cube you are having. Okay, all right, so this cube you are having. This is the zoomed part. I think you are getting the flavor. Okay, fine. So here you have this function f. Okay, and dv means here dx, dy, dz. dv stands for this fellow. Okay, no need to worry, just simply try to find your divergence of this vector. So divergence means this dot this fellow. So del f del x plus del f del y plus del f del z. Try to find out. So it is del f del x del f del f1 f2 f3, where this components, this one is f1, this component it is f2, this component it is f3. Okay, so you have 4z minus 2y plus y, 4z minus y you have. All right, okay, so plug this value of divergence of is equals to 4z minus y here in this formula. So you have this one 4z minus y dx dy dz. Okay, so you have x equals to 0 to x equals to 1, 0, y is equals to 0 to y is equals to 1, and z is equals to 0 to z equals to 1. 4z minus y dz dy dx. Just changing the order of integration, and do the rest of the portions on the calculation. Rest of the things are only about calculation. So here x equals to 0, y is equals to 0. Here look at, you need to integrate this fellow with respect to z. So you have 2z square minus yz. Take the limit and rest of the things will be like this way. Okay, fine. So here we can proceed. So after this step you have this, x is equals to 0 to x equals to 1, then you have y is equals to 0 to 1. Here you have 2 minus y dy dx. X equals to 0 to 1, 2y minus y square by 2, 1 0 dx. Fine. Okay, x equals to 0 to 1, 2 minus of dx. So do this calculation and you will find 3 by 2 as your answer. Yes, it is 3 by 2 as your answer. So the answer will be 3 by 2. You can verify by yourself and be careful with the calculation. Okay, so here I am ending this video. You can do such problems by yourself and verify, and in the next video we will cover some of the questions related to this topic as well. Okay, so meet you soon in the next video. Bye.